Okay, so today we're gonna learn what is Opamp. So you can see the full form of Opamp is operational amplifier. Okay, so OP stands for operational and AMP stands for amplifier. Okay, so why it's called operational? It's because many mathematical operation such as summation, subtraction, multiplication, differentiation, integration, etc. can be done using designing the circuit with Opamp, and it amplifies the signal. That's why it's called amplifier. So as a whole, that's why it's called operational amplifier, op amp. Okay, so now the op amp is a direct couple amplifier, means there is no use of capacitor for cascading the amplifier stages inside the op amp IC. Okay, op amp has a very high gain and a low output impedance. Now the basic symbol of op-amp is this. Okay, so minus and plus, actually two inputs are there. These two pins are inputs pin. Okay, this is called inverting pin, and this is non-inverting pin, and this is output pin. Now pin diagram of IC741. So consider this is IC741. So there are 8 pins are there. Number 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so pin number 1 and pin number 5 for offset null adjustment. So these two pins 1 and 5 diagonally, you can remember this is for offset null adjustment. Okay, and then pin number 2 and 3, these two inputs are, these are inputs pin. Pin number 2 is inverting pin, which is labeled with minus sign, and this is non-inverting pin, which is plus. Okay, and to operate this IC, okay, we generally use a 12-0-12 DC power supply. Okay, so this power supply is connected in between the pin 4 and 7. So in pin number 4 we connect minus V, which is practically minus 12 volt, and in pin number 7 we connect plus V, which is practically plus 12 volt. Okay, and finally pin number 6 is the output pin. Next, so from here we can recall, this is pin number 2 inverting, this is pin number 3 which is non-inverting. You can see from the pin diagram, two inputs are pin are there, pin number 2 and pin number 3, which is inverting and non-inverting. So using the IC symbol, op-amp symbol, pin number 2 is this and pin number 3 is this, and output pin is pin number 6. So the ideal characteristics of op-amp, the first one, open loop gain is infinite, but practically the open loop gain, which is represented by A, is nearly about 2 into 10 to the power 5. What is open loop gain? Now whenever an op-amp, in op-amp there is no feedback applied, means there is no circuit connected in between the input and output terminal, then the ratio of the input and the ratio of the output is called open loop gain. When there is no feedback applied to the op-amp, that open loop gain must be infinite ideally, but practically it's 2 into 10 to the power 5. Next, point number 2, Zi input impedance must be infinite, but practically it is order of Zi, it's order of mega ohm. Now what is input impedance? Consider the symbol of the op-amp. So in between inverting and non-inverting pin, internally inside the op-amp, there exists an input impedance. It's called input impedance of the op-amp. This is pin number 2 and this is pin number 3. So in between inverting and non-inverting pin inside the op-amp IC, an impedance is playing a role. This is called ZI input impedance. Next, point number 3. Point number 3. The output impedance of the op-amp must be tends to 0, but practically it is a raw 50 to 100 ohm. Again, the output impedance is this inside the op-amp. Next, point number 4, that the bandwidth of the op-amp must be infinite, but practically it's not infinite. Bandwidth is a frequency response of the op-amp. So if we draw a curve, gain versus frequency, then different circuit gives different types of frequency response over the gain. But I'm drawing a simple curve. So from this curve you can make an idea what is bandwidth. Say this is f1 and this frequency is f2. So you can see this in between this f1 f2 region, the circuit is giving the maximum gain. So for that particular circuit, f2 minus f1, this frequency range is called bandwidth. So for ideal characteristics of op-amp, the bandwidth must be infinite, but practically it's not infinite. Next, point number 5. The op-amp should be perfectly balanced. Op-amp should be perfectly balanced. Perfectly balanced means when there is no input applied to the op-amp, there must be no output voltage. Then the op-amp should be perfectly balanced. But in practice, if we do not apply any input voltage to the op-amp, due to the internal mismatch of the circuit inside the op-amp, we get a voltage. This is called output offset voltage. So in practically, an op-amp is not perfectly balanced. Okay, so whenever there is no input applied to the input, we get a output voltage. This is called offset voltage. To eliminate that offset voltage, we have to adjust the op-amp offset null using the offset null adjustment method. But ideally, op-amp should be perfectly balanced, but practically it's not perfectly balanced.